As I just explained, and the approach that I'm about to show you guys is geometric work. Then, algebraic way to solve this type of problem is taught in UC Scout instructional videos. So I need you guys to check both. And you can pay really good attention while I'm explaining. If you need more time in processing steps, and please do not forget to check out the recorded video that is gonna be uploaded this afternoon. All right, okay, so then let's start 4.8, finding trig values. And as usual, I picked examples directly from the practice problem, so you can see all the strategies that you need to do that assignment right away. So make sure you do it if you haven't. I know a lot of you guys didn't, right? So do it right after. Okay, so let's start it. Well, what do we have here? Okay, that the problem says, for an angle theta, if tangent of the given angle gives you the exact value -4/3, and the angle is placed between 3π/2 and 2π, then this is enough information for us to investigate, and we should be able to find the exact value of sine of whatever that angle. We don't even know what exact angle, but somehow this is enough information for us to figure out all the other 6 trig ratio. It seems like it, right? Okay. So then, as I just explained, I will show you the geometric approach here. And of course, I need quadrant, so that we can see what is going on the coordinate quadrant, coordinate plane here. Okay, so now we see there's a quadrant. And first of all, let's verify which quadrant that angle theta is placed. The angle theta, the terminal side of the angle theta, should be placed between 3π/2 and 2π. Then let's remember how we can verify the position of each angle all over the unit circle quadrant here. Where do we start? Right here. This is 0. Here 0. Then we go counterclockwise. Where is π/2? Right here. Then keep going counterclockwise, and then now I see pi. And where is 3π/2? 3π/2 is here, and it goes back, and then it's the same position, but it's also 2π. Okay. Then where do we see the possible position of the angle theta? Between 3π/2 up to 2π. So between this position, this region, so consequently it gives us, it's limited between quadrant 4. This is quadrant 4. Quadrant 1, 2, 3, and this is quadrant 4. Okay. Then again, now tangent theta gives you -4/3 as the exact value. And the terminal side of whatever this angle theta is in quadrant 4. So now what we can utilize here is the reference angle that we learned in the previous semester. Reference angle, we find the terminal side position and nearest x-axis. So this has to be here. Somewhere in quadrant 4, I recognize my terminal side of the angle. Then with x-axis, it's gonna make this angle measure. Then we call it, it's reference angle of the original angle theta. So now I have the apostrophe on top of it. Then also I can construct right triangle in quadrant 4 like that way. Then where is the right angle of the triangle? Right here. Then where is the angle theta and its reference angle? Right here. Then around this, I can verify hypotenuse here, opposite side here, adjacent side here, around that angle theta apostrophe right there. Okay, you follow my logic? So first of all, we verify we're dealing with in quadrant 4. Then terminal side is placed in quadrant 4 and I can utilize this reference angle, right triangle with that direction. Then I can verify my position of the reference angle theta apostrophe right there. Then around that angle, I can find hypotenuse, opposite, adjacent like this. Then come back to the original information. Now with this angle, whether it's original theta or reference angle theta apostrophe, they're all same. Then it says tangent, whatever the angle, has -4/3. But tangent is what? Okay. Adjacent, right? So then the opposite must be -4 and the adjacent must be from 0 to the right, and then it's +3. So right here is 3, 0. And this must be 3, -4, right? -4. Okay, then now it makes sense. Then in order to find sine, so then let's see what ratio makes the sine. Sine of that angle will be opposite over, now it's a hypotenuse. Then we need to know the hypotenuse. But how can I find the hypotenuse though? Well, we have that powerful weapon. It's called Pythagorean theorem, right? So then hypotenuse square is 3 squared plus -4 squared. It's 9 plus 16 is 25. Then in order to get the length only, square root both sides, and hypotenuse must be 5, right? Hypotenuse is 5 here. Then we're done. So what's opposite? -4. What's hypotenuse? 5. Isn't it easy? If you see how you can utilize the reference angle and the reference right triangle in each quadrant, then it's gonna give you everything. So in that case, you can come up with all other 6 trig ratio, no problem. In fact, there's exactly the same problem, but it's asking cosine. No problem. What only difference is, so cosine of that angle is adjacent over hypotenuse. Then adjacent over hypotenuse. Adjacent what? 3. And hypotenuse what? 5. And that's it. So you can get everything right there on the quadrant. Okay, so this was our first time look at the situation like this way. So if you are not familiar to this, and then it's totally fine. Okay, and then any question? Okay, then let's do similar problem once again. Okay, hoping that we get used to this. Okay, clear. Example number 2. For an angle theta, now we're given with the secant of whatever the angle gives you exact value 3. And also 3 pi over 2 to 2 pi, that means we're dealing with same quadrant 4. Then let's pull our quadrant out here. Then again, we can see 3 pi over 2 and 2 pi. So it's obviously quadrant 4 again. Okay, then let's prep our information given here. So it says secant of the theta is 3. But secant is not the basic trig function that we're familiar to. So let's rewrite it. Secant is nothing but reciprocal of cosine. So this gives us cosine of the same angle is, instead of 3, it's going to be reciprocal of 3, 1 over 3. Then again, we can still utilize the same reference right triangle in quadrant 4 with this position. So let's say the terminal side is somewhere in the quadrant 4. Then my opposite side will be this. And where do I put the 90 degree? Right there. Then where is my reference angle? Here, because the terminal side end not with y-axis, but with x-axis. So now I see my angle position inside of the inscribed right triangle there, right? So then cosine was adjacent over hypotenuse, right? So where is adjacent? This is adjacent 1. And where is hypotenuse? This is hypotenuse 3. Then what's missing from us is opposite. And also we need that for sine anyway. Sine is opposite over hypotenuse. So how do we get that? We can use the Pythagorean theorem. So now, how long is hypotenuse? 3 square is what plus what? Adjacent 1 square plus, now this is opposite. So then opposite square. So then this is 9, it's 1 plus opposite square. Then minus 1 will make 8. And then it's opposite square. Okay, let's rewrite it as opposite because it looks like a 0 square. Okay. Opposite square, opposite square, opposite square. So then 8 is opposite square, then square root both sides. Then it's gonna be square root of 8 is the dimension of the opposite side. Okay, then this is square root of 8. But remember, the coordinate of this vertical is below 0. So then this has to be what? Negative. This has to be negative. Because it was supposed to be plus minus square root of 8 anyway. And then in this case, because of the position y on the quadrant, we are supposed to have the vertical going down. How many units? Square root of 8 units down. So it makes sense mathematically, right? So it's a negative square root of 8. Then sine of that angle, no problem. So it's opposite over hypotenuse, opposite negative radical 8, hypotenuse 3. So we found it. Then continuously with the same situation, it's asking cotangent, no problem, okay? Then cotangent of the theta is reciprocal of what? Tangent. So let's find tangent first. Tangent is opposite over adjacent, right? So tangent will be opposite negative radical 8 over adjacent 1, which is negative radical 8 but it's cotangent, right? So then this means cotangent of the angle is 1 over radical 8, but it's negative. Then this is right answer, but somehow you would not see this answer choice among that group of answer choices there. And it's gonna be the matter of rationalization that we learned earlier. So rationalization will require you to multiply the radical value from the denominator top and bottom. Then it's negative radical 8 over square root of 8 times square root of 8 makes denominator 8 there, okay? Then you will see the answer there. Question. All right. Example number 3. Okay. Now, if cosecant of an angle is -2, which quadrant is the terminal side of the original angle theta in? Select all that apply. Then, now we just saw how the quadrant affects the sign of all trig functions here, right? Then let's go through what is actually happening sign-wise all the way one circular motion over this 4 quadrant. So if we focus on quadrant 1 here, now the reference right triangle will be posed in this way, in the right angle is right here. Then hypotenuse is always positive. Then around this angle, the adjacent is positive, opposite is positive. Then the hypotenuse is always positive. So it makes all 6 trig ratio is all positive because it's all make positive over positive. So all 6 is positive, okay? And it looks like X, so let me erase this. And it's positive. Okay, then let's move on. Quadrant 2. Then quadrant 2, the reference right triangle is here. Then the reference angle is inside of the right triangle. This is right angle. Then hypotenuse is positive. But now in this case, what? Adjacent is negative, but opposite is positive. Opposite is positive. Opposite is positive. So positive, positive is positive, but negative, positive will make negative. So only sine of the angle in quadrant 2 will be remaining positive. Because sine is the only ratio that gets hypotenuse and an opposite, and then they are both positive. Then let's keep exploring in the next one. Now if I have any terminal side in quadrant 3, this is right angle, and this is hypotenuse, and then this is the reference angle here. Then hypotenuse is always positive. Then now the adjacent is negative, and also the opposite is negative. So in this case, only trig function that gets positive is tangent of that angle there, because tangent ratio is opposite over adjacent, which is negative over negative. So tangent is only ratio that gets negative over negative, which makes positive. Then the last one here is quadrant 4, and this will be the reference angle, and right angle is right there. Then we've been working on quadrant 4, so we are already familiar. Then as you see, the cosine, so this is positive, this is negative. So the cosine, which is adjacent over hypotenuse, is positive, remaining positive in quadrant 4. So if you remember, or if you understand how it works in each quadrant, and then it's gonna be really powerful weapon for you guys to figure this type of problems out, right? So then now it comes really easy to answer this. So then they ask, cosecant is -2. That means sine of that angle is -1/2. Then sine and cosine are negative. In quadrant 1, nothing is negative. Quadrant 2, the sine and cosecant will be positive. So only possible quadrant for sine and cosecant remain negative is quadrant 3 and quadrant 4. So you pick quadrant 3 and quadrant 4. So that's the answer. Okay, any question? Okay, then we have only one example left. So let me save it. Okay, the last one. Okay, then for an angle theta, secant theta is radical 2, and it's in between 0 and pi/2. So which quadrant is that? So quadrant 1, because this is 0. Where's pi/2? Pi/2 is here, so it's happening in quadrant 1. Then secant is radical 2 means, cosine of that angle is 1 over radical 2. And also in quadrant 1, we can utilize this reference angle and right triangle posed in this way. Then if cosine is 1 over square root, then the hypotenuse is square root of 2, and the adjacent is 1. So this is adjacent, and then this is 1 here, right? Then we have to figure out the opposite. So how do we find it? We can utilize Pythagorean theorem. So hypotenuse is square root of 2, but it's gonna be squared. And the one leg is 1 squared. And then the opposite square, right? So then square root of squared is 2 is 1 plus opposite square. Minus 1 won't make opposite square is 1. Then that means opposite is also 1. Then where is it? So this is supposed to be 1, okay? Even though it doesn't look like the same length, but it's supposed to be 1. Then we remember this one as one of the special right triangle that we learned. That was the ingredient for us to use to construct the unit circle from the beginning. And this one was the isosceles right triangle that gets adjacent and opposite leg the same length. And then we remember that angle, this is 45 degree right here, right? 45 degree. And that's it. Then we are finding tangent, so it's easy. In this case, tangent of that angle is the opposite over adjacent, it's 1 over 1, which is 1. So that was very simple. So now I hope you guys can use this geometric approach to solve these values here, okay? And let me know if you have any questions. And also try both of the method when you do the practice problem. And wait for my email, including the instructions for IAB test for Thursday.